Inverse functions. As the name suggests, an inverse is when we swap things around. The whole purpose of an inverse function is to swap the x and y around of a regular function and then create a brand new equation. This is very useful when we want to go and create different shapes in space, or alternatively different functions in space. The thing is, though, to create an inverse relation is very, very easy because you can just swap things around, it's okay. But to create an inverse function, the way that you transfer it around, when you tilt or swap x and y's around, the final product still has to obey a vertical line test, things like that. So we find that in order to make a function inversible, the original one has to be a one-to-one function. But we'll cross that bridge as we get to it. So what I've got here is we've got an delightful little opening problem here, where I've got the graph of -1 over x minus 2 plus 3. So it's half of a hyperbole. And notice the domain says 2 to positive infinity. So I've just cut it in half. I've put in my asymptotes here. So they are at x equals 2 and y equals 3. If I didn't have them drawn, that's what gets me the y equals 3 asymptote. And then this gets me the x equals 2 asymptote. So just as a reminder, draw the line of y equals x on the graph. Okay, so what we'll do is we'll get a couple of points. So y equals x, so -2 and 2, we'll put this line here. And then what we'll do, in fact, what I might do is put some end points. That might make life a little bit easier. And then imagine the graph of y equals x acts as a line of symmetry. Copy what the graph would look like on the other side of the line of symmetry. And herein lies the concept of an inverse. When I swap x's and y's around, I'm basically going to make a mirror image of the graph along that line of y equals x. Now, I find it super difficult, especially when you've got asymptotes and all that kind of nonsense in, to visualize it on that angle. So what I've done here is I've actually tilted it around. And so just to get an idea, first and foremost, I'm just going to go and get rid of the asymptotes because they're a little bit more difficult to see. What I'm going to do now is I'm going to put that y equals x line in there, but you see I've tilted the axes, so it actually should look fairly straight on, hopefully, if I have done this even remotely accurately. There we go. So there's my y equals x line. So now all I have to do is draw the mirror image of that. So the mirror image here, this is that asymptote was going through 2 here. And so that little x-intercept is a little bit greater than 2, so that's going to be over here. And then it's sort of tilting and bending towards what would be y equals 3. So it would be tilting and bending towards x equals 3 in this instance. So that'll be about here. So it should be bending towards that. And then it should look something like that. And now we've got our beautiful mirror image of our graph. So there's our inverse function. So this one here, we'll label that as the inverse. You'll notice that I've got a little -1 at the top there, because if you have a to the -1, that is 1 over a, and that fraction is referred to as the inverse of a. So that's just a fun naming fact. So by that logic, what we can do here is we can also now input back in our asymptotes. We know the inverse. We know it's heading towards this 2 here, because that's this pattern here. So that's where the new asymptote is going to be here. And the new y asymptote is going to be at about 3. Oh, sorry, x equals 3. So x equals 3 is the asymptote for the inverse function. And it's still an inverse function because it's a one-to-one function, just the blue line. I'm ignoring the original. And then y equals 2 is our asymptote for the inverse. So we've imagined it, we've tilted it around, we've drawn it. As a fun fact, I highly recommend there'll be some questions in the textbook where you're expected to draw the inverse. May I suggest tilting it in this way? I just find it so much easier to do so. We have established where the new asymptotes would be, so it'll be at x equals 3, y equals 2. Given that the other equation is still a hyperbola, write the equation. So yeah, it's true, it's going to be still in the form of 1, or, you know, a over x minus h plus k. So now we just need to fill in those values. So we know that the vertical asymptote is still at x equals 3, so that's going to be x minus 3. We know it's gone up by 2, so I just need to find this value of a. So what I might do is I might substitute. Have I got a lovely value that I can substitute in here at all? That I do not. Nothing that I know for certain. Although, wherever the x-intercept will be, I know that if I, because this whole thing about inverses is I swap things around, wherever the x-intercept will be, that will become the y-intercept of our inverse function. So, we know it's a little bit after 2. So let's find the x-intercept by solving that. So if we go 0 is equal to negative 1 over x minus 2 plus 3. So negative 3 is equal to negative 1 over x minus 2. X minus 2 is equal to 1/3. X is equal to 2 and 1/3. Well, by that logic, which we don't like mixed numbers in methods, so it's going to be 7 over 3. I dare say that our y-intercept of our inverse is going to be 0 7/3. So I'm going to substitute x equals 0, y equals 7/3. 7/3 is equal to a x minus 3 plus 2. 1/3 is equal to a over x minus 3. And then we'll have x minus 3 is equal to 3a. And then we'll do... Oh, what am I doing? That should be 0. Idiot. There we go. So what I can do instead... Sorry, that's my bad. Let's try that again. 1/3 is equal to a over 0, take away 3. So if I multiply both sides by negative 3, that becomes negative 3 over 3 is equal to a. A is equal to negative 1. So therefore, my graph should be... the inverse function should be negative 1 over x minus 3 plus 2. So there we go. So that's how we can find the equation using that graph. But I'm also going to go and show you what is the standard procedure, algebraic procedure that we can do. I just wanted to show that as an alternative strategy based on the information that we have so far. So what I'm going to do here is I've got this set of instructions. In order to get our one-to-one function, we have to check to see if the original is a one-to-one, so it needs to obey the horizontal line and vertical line test. If it doesn't, we need to restrict the domain such that it does. Swap the domain and range around, swap the x and y around, and solve for y. So we've got this many-to-one function, which is an x plus 4, x minus 2. So it's going to look something like this. 2, 0, negative 4, 0. So what we're going to do is we know that that is not a one-to-one function, but we need to restrict the domain to get the largest positive one-to-one function domain. So what that means is that I need to cut this in half such that I have a very positive domain. So I've got the positive numbers. So it needs to be the largest, so I need to go all the way to the turning point, because that's going to be the largest. As soon as I go back further, if I took that yellow highlighter and gone back further, then it's no longer a one-to-one function, because I won't be able to do a horizontal line test. So we need to find the turning point. So the turning point is going to be smack bang between -4 and 2. So that's going to be at what? So that's a distance of 6. So halfway would be 3. So that's going to be at -1. And then we're going to go to positive infinity. So that's what we're going to restrict the domain. The range of that, well, we better find where that turning point is. So I'm going to substitute -1 into my equation, so I know where the y value of the turning point is. So it's 3 times -3, so that's going to be -9. And so that means that's my lowest value, and it goes up to infinity, so it's -9 to positive infinity. We need to swap the x and y around in the original equation, so because, hang on, did we skip it? Oh, we did. Swap domain and range around. Well, this will be the domain of the inverse, and this will be the range of the inverse. So we need to make sure we've got that. We know the range and domain of the inverse. Going to swap the x and y around, so we're going to go and get x is equal to y plus 4, y minus 2, and now we need to solve for y. This one will be a little bit tricky because we've got 2 y's in here, and it's not going to be a very nice quadratic or anything like that because we've got this x on the side. Therefore, you see I've put a hint, you'll have to complete the square, because basically what I want is just 1 y on one side and 1 x on the other. That's what I want. And you'll see why I'm doing this. Y. X equals y squared. So I'm just expanding these brackets. Y squared minus 2y plus 4y equals -8. Y squared plus 2y minus 8. And now I'm going to complete the square. And in case you don't know how I got to that step, that's going to be y squared plus 2y plus 1 over 2 squared. No, hang on. No, I was right. 2 over 2 squared minus 2 over 2 squared. It's going to be 1. Minus 8. So that's how we do that. And the interior of that bracket goes in the inside here, because this becomes a perfect square. Blah, 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 blah. So that becomes y plus 1 squared minus 9. And now what we need to do is now to get y on its own. So what I'm going to do is then add 9 to both sides, and I get x plus 9 is equal to y plus 1 squared. I now need to take the square root of both sides and get the square root of x plus 9 plus or minus y plus 1, and then minus 1 on both sides, and I get y is equal to -1 plus or minus the square root of x plus 9. You see the plus and minus there? So you've got 2 choices. So we have to make sure we have the one that will result. We have to choose one of them. We need to make sure that we have whichever one will have the range of -1 to positive infinity. So remember that a square root graph, a positive one looks like this, a negative one looks like this. So -1 minus, so if I was just to highlight that one, the minus, that's this one down here. Whereas the positive one is the one up here. So considering that we want the one that has the positive range, this is the one that we want. So this is going to be y equals -1 plus x plus 9. You must be able to discern that. Now, I should get rid of that y and put the inverse function. Always label it as the inverse function. So one of the things that we normally would do when we're solving for this is that we actually put, see this little instruction for C? When you're doing a working out for an inverse function on your own, make sure you write that statement. Because if you go from y equals x plus 4, x minus 2 to x equals this, that's rubbish, that's bollocks. The x's and y's do not equal each other in this way. You have to have this statement. So this is a must write this before you go and solve it. So hence, what is the function of, or the equation of the inverse? Write it in function notation. So I'm going to write it as f1, and the domain of the inverse is -9 to positive infinity to all real values. The inverse is equal to -1 plus the square root of x plus 9.